Welcome to October's Leetcode Challenge. Today's problem is minimum domino rotations for equal row. In a row of dominoes, A and B represent the top and bottom halves of the ith domino. We may rotate the ith dominoes so that AI and BI swap values. Return the minimum number of rotations so that all the values in A are the same or all the values in B are the same. Either the top row are all the same number or the bottom row are the same number. So there's a big temptation here to start thinking recursively. How could we swap these values? How can we find all the, do some backtracking and get the base condition where all the values are going to be the same? But I would suggest you don't go that route. Rather, think about what conditions need to be met for our top row or bottom row to all equal the same value. So forget recursion, just think about this straightforwardly. Well, if we were able to swap values and all the values would be the same on the top row or the bottom row, we could look at the very first item on both A and B and check our values. Here it's 2 and 5. What we should do first is make sure that this is even possible. We can take our value 2 and check to see if 2 exists on every I index between A and B. So here with 2, we can see 2 is in index 1 on B, it's in index 2 on A, index 3 on B, and 2 on A. So that means that we could swap values and get all the values to be 2 on either the top row or the bottom row. If, for instance, for 5, we can see 5 does not exist in any of these indexes, but even if it didn't exist on 1, then we wouldn't be able to swap index values to get all the rows to be that's value 5, right? So that's the first thing we'll do. We'll go through our A and B and check to see if all the values between the top row and the value on the bottom row exist in between A and B. So is this even possible? All right, so the first thing we'll do is initialize our n. That's going to be the length of A or B, doesn't matter because they're equal to one another. And I suppose we can just say if not A, return -1 for an edge case. So let me comment this out. So first, is this even possible? Well, to do that, let's take our values 1 and 2, which will be value on the top row and the value on the bottom row on the very first item. So this would be A0 and this would be B0. So if this was possible, either V1 or V2 should be on every index value between these indexes. So for I in range of, we can start with 1 since we already took the first value, to n, is V1 in either, let me make a tuple, AI or BI. And all of this should be true, right? This is going to be true for all these if V1 is the value that we're indeed checking for. So what I'll do is make this a list comprehension. I'll make this a list. And if all these are true, then it's that V1 value that we're looking for. Then we can go through also and check the bottom value and check V2, same thing. So here I can call this, let's say, I can say it's on the top value or the bottom value. So if both of these aren't true, then we could return a false. Or rather, we return -1 because this isn't possible. Otherwise, we have indicated one of these two should be true, right? Now, it's possible both of these are true, but if that was the case, then that actually means that it's an equal number of values for 2 and 5 between these two rows. So the minimum number of rotations would be the same. If they were both true, then they're like equivalent, so the answer would turn out to be the same. So we can keep that in mind, and we'll say, all right, here we'll check which value should we check to see. And once we check that, all we need to do is go through the top row and the bottom row and see how many of those are not that value. So here we're already chosen 2. We know that 2 is going to be the value that we want to make equivalent. For the top row, we can see that there's 2 values that are not 2. And we know the 2 is on the opposite side, right? So we can just count these up. We can say, well, 1 isn't equal to 2, but we know it's on the other side, so rotate that. And 4 isn't equal to 2, but we know it's on the other side, so rotate that. So that's a value of 2. There's going to be 2 rotations to get all 2's on the top row. What about the bottom row? Well, we can see that there's 3, 5, 6, and 3 that are not 2, so that would take 3 rotations. So between that, the minimum number of rotations would be 2, so that would be our answer. Okay, so if top value, we're going to take V1, check to see V1, and we will, I apologize for the noise, initialize an output like this. So if top value, what are we going to do? All we need to do is check to see which values on both A and B are not equal to V1, right? Okay, so for I in range of n, if this value for A of I is not equal to V1, then we'll just output a 1, and we'll get the sum of that. And this would be the minimum number of rotations for the top row. And same way we'll do it for the bottom row. We can just do for B right here. And between these, the minimum between these is going to be our output. All right, so I realize that's a handful, but hopefully you're getting it. Now, else if the bottom value we are going to check for V2, not V1, V2 and V2. Finally, once we're finished there, we just return our output. Okay, so let's make sure this works. This should return 2, and it does. Let's submit that. And accepted. All right, so this was a straightforward answer, right? I realize it's all over the place. We could simplify with some other methods, definitely optimize. Is this optimal? Well, it's O of n, but it's definitely not the optimal solution, but it does work. I don't think I'm going to go too much more into this than that because it's pretty straightforward. So thanks for watching my channel, and remember, do not trust me. I know nothing.